Okay, so just go over what we learned today in algebra and what we were talking about, Algebra 1. We did some review of the distribution property. So, for example, number 1, we have 2 quantity 3 plus 4. And what we're looking to do here is distribute this 2 inside. Now, you could do mental math and do 3 plus 4, which equals 7, and then take the 7 and multiply it by the 2. But here, we're going to show you how you do this. So the 2, we're going to multiply it by the 3, and then we're going to multiply it by the 4. So here, the 2 gets multiplied by the 3. That equals 2 times 3. And then here we're going to do the 2 times 4, which is 2 times 4. So here we've got 2 times 3 and 2 times 4. And that's how we distribute the property. So here we go ahead and do our math. 2 times 3 is 6. Bring down the plus sign. And 2 times 4 is 8. Now we've got 6 plus 8, which equals 14. Again, this is very similar to if we had done it the other way of just adding the 3 plus the 4, which would equal 7. And then we multiply that by the 2. 7 times 2 is 14. So that's the distribution property, where we distribute this number that's outside of it into each term that's inside the parentheses. Okay, here's another example of this. 2 plus 3, and then a 4 outside of it. Now remember, something we had mentioned too is that multiplication in algebra is the default operation. That means if you don't see an operation sign of like a plus or a minus or a division, if there's no sign, which there is no sign here, then it's multiplication. So that's why this 4 is being multiplied by everything inside here. So, much like we had said before, you could take the 2 plus 3, which equals 5, and then 5 times 4, and that equals 20. But let's look at how we do this distribution-wise. So we're going to, and it doesn't matter if the 4 is on this side or if it's on this side. If it's outside the parentheses and there's no operation sign of a plus, minus, or division, then we know it's multiplication. So here we have 4 times 3. So we're going to write that down. And then 4 times 2. And then here we bring down this plus sign. So basically we're taking the 4 times the 2, putting it here, and the 4 times the 3 and putting it here, and then the plus, we're adding both of that together. So 4 times 2 equals 8. 4 times 3 equals 12. Again, bring down that plus sign, and now we've got an 8 plus 12, which again equals 20, much like we'd shown before. So that's the distribution property. A very common mistake that I see here, and I mentioned it in class today, is students will remember to multiply 2 times 3, but they'll forget to also multiply it by the rest of the terms. So they'll do 2 times 3, which is 6, and then they'll just bring down the 4, and that's not correct. You have to multiply this number by everything inside the parentheses, okay? So let's look at this next one. Here we have A multiplied by quantity B plus C, okay? So again, we want to multiply the A by the B and the A by the C. So here, just like we did before, we're going to take A times by B and A times by C. And again, we're bringing down this plus sign because that's what was in the middle to begin with. So A times B plus A times C. These dots represent multiplication. There's different ways you can write multiplication. You can write it A times by B, but then that is confusing because is this an X variable or is it a multiplication sign? That's why in algebra, we no longer write the X for multiplication. We write a dot instead. So here we've got A times B and A times C. Now again, when we've got two variables, we don't next to each other, we don't have to write the multiplication sign, so we can just write it A, B plus A, C. These both are the same thing. It's just the multiplication sign is invisible. And again, you don't have to write it because multiplication is the default operation in algebra. So if you see two terms next to each other, or two variables next to each other, or even a coefficient and a variable next to each other, that means multiplication. There's an invisible multiplication there. So that's what we got here, AB plus AC. Can we add these? Are they like terms? Well, here we've got AB, and here we have AC, okay? So no, we don't have to. We can't combine the like terms. So this is about as far as we can go. Okay, next, we've got quantity X plus Y and then Z, okay? So the Z is outside of the parentheses. There is no operation sign of a plus or a minus or a division sign, so we know this is multiplication. So what do? Take a moment, see if you can figure it out. Okay, so yep. If you haven't done it yet, pause it, but I'm going to show you. Here, again, the Z is going to get multiplied by the Y. So we're going to write Z, Y, and I don't have to put that invisible multiplication sign in here. So it's just ZY. And then the Z is also getting multiplied by the X, ZX. Okay? And we're going to bring down that plus sign because these two terms are being added together. Okay? Something Mr. Pacheco said, this is correct, but standard form says we should do it in alphabetical order. Which comes first in the alphabet, Z or X? X does. So we're going to rewrite this as X times Z. And again, we don't have to put that multiplication sign there because it's invisible. And here, which comes first, Y or Z? Well, in the alphabet, it's Y. So we've got Y, Z. Let me put the plus. You're going to see why it's important to write it in standard form because it eliminates confusion. So you'll see a little bit later on. So now we've got XZ plus YZ. Okay? Are these like terms? No. What makes something a like term? They have to have the exact same variable. This variable set is XZ, this is YZ, so they are not like terms. Now, let's see if you can do this. We have 4 times quantity 8 plus 3. See if we can solve it. Okay. Hopefully you've done your math. Pause it if you haven't, because I'm about to show you. Here we have 4, and we have to distribute this 4 inside to both terms. So here we're going to do 4 times 8. 4 times 8. And here we're going to do 4 times 3. You don't have to do this step, But if you are new to the distribution property, or if you keep forgetting to do it by the second term and you're only doing it by the first term, then I would say keep this step in here and write it so that you remember until you remember to do it to both sides. So here, we're going to bring down the plus sign. And now, let's do the math. 4 times 8 is 32. 4 times 3 is 12. Bring down our plus sign. Now we have 32 plus 12. That equals 44. All right, next. We have 1/2 times quantity x minus y minus 4. Pause it if you want to try to attempt it yourself first. Here we have the distribution property, so we're going to put these in for each one. So 1/2 multiplied by x is the same thing as 1/2 x. Again, that invisible multiplication sign, we don't have to put it here because we know we've got a coefficient and we have a variable next to each other, so that's automatically multiplication. And then we're going to take the 1/2 and also multiply it by the y. So we're going to put 1/2 y. And then we're going to bring down our minus sign because we're subtracting these two terms still, okay? So now we've gotten rid of the 1/2 and the x. We've gotten rid of the 1/2 and the y, okay? And now this, do we have to multiply the 1/2 by the -4? No, we do not, because the -4 is outside the parentheses, and this is only being multiplied to everything inside the parentheses. So we're just going to bring down the -4 now that we've distributed. Now we want to look, can we combine any of these? Do they have like terms? What makes something a like term? The variable. Do any of these other terms have an x in it? A variable of x? Nope. What about here? Do any other of the terms have a y variable? Nope. What about this? Do any of the other terms not have any variable? No, they don't. So this is as far as we can go for our answer. Now, something that Mr. Pacheco had also mentioned is in regard to multiplication of signs. So he had mentioned we have some people do a triangle. This is the way it was taught in Eureka Math. You put a plus at the top and then a negative sign, or a minus sign and a minus sign. So what you're going to do is if you have a positive and a negative, then you just put your finger over the positive and the negative, and whatever's left, that's what your answer is going to be, negative. If you've got a negative times a negative, put your fingers over that, and what's left? You've got your positive. Okay? And that's one way of doing it. The other way of doing it that Mr. Pacheco had shown is if we have one negative term, then our answer is going to be negative. If we have two negative terms, then our answer is going to be positive. If we have three negative terms, then our answer is going to be negative. And so what he had mentioned here is here we have an odd number of negative signs. Here we have an even number of negative signs, so our answer is positive. And again here we have 3, so that's also odd, so our answer is negative. So when we have even numbers of negative signs, then it's positive. If we have odd number of negative signs, then it's negative. Okay? All right, let's go here, see if you can figure this one out. We have 6 plus x minus 5 plus 7. Okay? What are we going to do? See if you can figure this out. So here, and we've got a plus. Are we going to distribute anything inside these parentheses? What are we going to distribute? Remember how I said if there's a sign, then it's not multiplication. Here we have a plus in between the 6 and the parentheses. Same thing here. We've got a plus in between the parentheses and the 7. So this is not multiplication. So instead, we're adding, and at this point, there's nothing else to be done. We just look inside the parentheses in order of operation. Can we do anything more? X minus 5 is the most we can do. So we can drop the parentheses now and just write x minus 5, bring down the plus 7, and now we have the parentheses gone. Next, we want to look at exponents. There's no exponents here because we're doing PEMDAS. So now we've got multiplication and division. Is there any multiplication and division? Nope. So we've got the plus, minus, and plus. So all we've got left is addition and subtraction, where we want to combine like terms. So are there any other terms? We've got one term, second term, negative 5, and positive 7. So on the 6, what's the variable? There is no variable. So are there any other terms that have no variable? We've got 6. Does the x have a variable? Yes, it is a variable, so that's not a like term. We have the negative 5. Is the negative 5, does it have a variable? No. So we can bring that down. 6 minus 5. So we've gotten rid of that. We've gotten rid of that. Now we've got a positive 7. Does the positive 7 have a variable? Nope. So that we can also bring down the positive 7. Okay? So we have positive 6 minus 5 plus 7. And now that we've gotten rid of all that, we can combine these like terms. Remember, we still have the x here. So 6 minus 5 is 1 plus 7 equals 8. So all of this here becomes 8. And now we can bring this positive x plus x. And that's as far as we go. 8 plus x. Now, let's look at the next problem. We have 2 quantity 2x plus 9. See if you can figure that out. Okay, so here we've got, let's go ahead and start this out. We have to distribute this 2 into everything because inside the parentheses, there's nothing else we can do. We cannot combine these because they're not like terms. This has a variable of x, and this does not have a variable. There's nothing more we can do inside the parentheses. So now we've got to do the distribution. So 2, so we're going to take the 2 times by 2x. And then we're going to take the 2 times by 9. So now we've got this term being multiplied and this term being multiplied with that. And we're going to bring down this plus sign. So now let's do the math. 2 times 2x, the 2's multiply and become 4. We bring down our x. And then 2 times 9 is 18. So now we have 4x plus 18. Now, this was the distribution property. Next we're going to do is the opposite of distribution, which is factoring, okay? So let's start off here. We have a factor of 4x plus 18. So what we're going to do is use the factor tree. Let's go ahead and factor things down. We're going to factor it to prime numbers. So what two factors can I break 4 down into? 2. 2 times 2. And that, they're both prime numbers. And the x, I can just bring that down because I only have one x. If it was x to the second power, then I would go ahead and put another one and put an x, but it's not x to the second power, it's just x. So that's as far as we can get that down. And now I'm going to do 18. What are two numbers that I can multiply by to get 18? Two factors. Well, I've got 2 and I've got 9. 2 is a prime number, but 9 is not. It can be broken down even further by 3 times 3. Now, and I bring this down, so we've got everything here. So now I've got 2 times x, and here I've got 2 times 3 times 3. So these are my factors. What I want to do now is look at, are there any common factors? I've got a 2 and a 2 and an x, and here I've got a 2, a 3, and a 3. Well, these 2's can be my factor, and then there's nothing else. There's no more. I'm left with a 2 and an x and a 3 and a 3, so there's nothing common between the two of them. The only thing that was common was this 2 and this 2. So this is what I'm factoring out. So my factor, I'm going to write here, is going to be 2. Okay? So the factor, I'm factoring it out, which is the opposite of distribution. So I'm going to have this 2 be on the outside of my parentheses. Okay? Now, one way to look at it is, what do I have left? Well, I've got 2x. So I can just put 2x. And the other one, I've got 3 and a 3. 3 times 3 is 9. So I can do 9 here. And then the two terms that I broke down are combined by a plus sign. So I can put a plus. And this would be my answer. 2, quantity 2x plus 9. Okay? That's one way of doing it. The other way, you can just look and say, okay, my factor is 2, so I'm going to write my 2 out here. And then I'm going outside my parentheses. And then what goes in the middle? Well, what can I multiply 2 by to get 4x? Well, I multiply 2 by 2x to give me 4x. So 2x, so 2 times 2x equals 4x, so that's good. Now I want to look at, what can I multiply 2 by to get 18? Well, 9. 9. And then again, both terms are combined by a plus sign. So that's another way of coming to the same answer. So let's see if we can figure this one out. I'm going to write this down and pause it and see if you can figure it out. We're going to factor out 12 plus 32y. You're going to want to figure out what is your greatest common factor. Remember to use the factor tree and go ahead and pause it. And now I'm going to go ahead and give you the answer. So let's factor it out. What are two numbers that I can multiply by to get 12? Well, let's go 4 and 3. 3 is a prime number, but 4 is not. So I can break 4 down into further, which is 2 times 2. I'm going to bring down my 3. So 2 times 2 times 3. And now I've broken those down to prime numbers. Let's break these down. I've got two numbers that I can multiply by to get 32. Well, I could do 4, and 8. And then I also want to do my variable, which is y. And since it's y to the first power, remember there's an invisible 1 up here for the exponent, there's only one y. So I'm going to put that down. Now I'm going to break down this into further. So two numbers I can multiply together to get 4 are 2. 2 times 2. And then 8, I can multiply 4 times 2. I'm going to bring down my y. So all of these are prime with the exception of 4. So I can break that down as well. So 2 times 2, and I'm bringing down the rest, times 2 times y, and then I got to bring these down. 2 times 2. It's a lot of 2's. But it broke down pretty much into 5 2's. So if I did 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That's how I checked my work. Okay, so now I'm going to look, are there any common factors between this and this? Yep. We have 1, 2 that we can block out. And then we've got another 2. But there's no 3's over here, and there's no more 2's, and there's no y's. So basically, I've got 2 times 2 and 2 times 2. That is 4, so my greatest common factor is 4, okay? Because I was able to take a 4 out of here and take a 4 out of here. Now, let's go to the next step. So I've got my 4. I'm going to write it outside the quantity. And what do I have left here? I've got 3. So I've got 3. There's a plus sign here, so I'm going to combining my two terms. And then I'm going to look at what I've got left. I've got 2 times 2 is 4. Bring down this. Times 2 is 8 times y, so 8y. Okay? That's one way of doing it. The other way we could do it, as Mr. Pacheco showed us, is, again, we write, let's do this in a different color. We can go ahead and write our 4 out here, and then think, what do I multiply 4 by to get 12? Well, it's 3. And what do I multiply 4 by to get 32y? 8y. Okay? And then I've got my addition sign right in the middle, so that's my answer. 2 different ways to go about it. Next, we've got 7x times quantity x minus 2. So we're getting a little more complicated now. Here we're multiplying 7x, and we're going to distribute it into this within the parentheses. We got to do it to both terms. So if you remember, when you have x plus x, that equals 2x because you've got 2 of them, okay? You've got 2 x's, so your coefficient becomes 2, and you got 2x. But when you have x multiplied by x, that equals x to the second power. So that's what this exponent means, is that we're multiplying x by itself 2 times. Same thing, if we have x times by x times by x times by x, we've got 4 x's that are being multiplied together. That would make it x to the 4th power. But if we had x plus x plus x plus x, that's going to give us 4x because we've got 4 of the x's being added together. So that's the difference. Exponents mean multiplying, repeated multiplication. We're multiplying the same thing over and over again. The coefficient means repeated addition. We're adding the same thing over and over again, okay? Very common for students to mix up coefficients and exponents. So here we're going to look at 7x times by x. Let's go ahead and write that down. 7x times by x. And then 7x times by negative 2. Okay? So 7x times by x, well, the coefficient is, here is a 1, an invisible 1. So 7 times 1 equals 7. Now multiply the variables together. X times x equals x to the second power. Now we have our coefficients. We've got a constant of negative 2 and positive 7. So here, how many negative signs do we have? We only have 1. So that's an odd number of negative signs, so our answer is going to be negative. 7 times 2 is 14. Here there's no variable. Here we have a variable, so it's just x. This is our answer. 7x squared minus 14x. Now we're going to talk about, we have quantity a plus b squared, or to the second power. And what that means is, again, remember that exponents means repeated multiplication. So that means a plus b, quantity a plus b times by, and we don't have to write that because, again, it's invisible. The default operation in algebra is multiplication, times by a plus b. Since we don't have to write the multiplication sign, we're not going to. So we've got quantity a plus b times by quantity a plus b. That's what this 2, this exponent of 2 means. We've got 2 of these being multiplied together. So, much like we looked at in the distribution factor, you guys had learned about FOIL, which is what we talked about today. FOIL, F-O-I-L. This stands for first. So here, our first is A, and A, it's the first term in both of them. So we're going to multiply these together. A times A. The O stands for outside. So that means we've got A, which is the outside here, and this is the outside here, because they're the outside of both of these. So A times B, which again is the same thing as AB. And then the inside is this B times A. And we could write it B times A, but remember that alphabetical order, A comes before B. And we'll show why that's important. So instead of writing it BA, I'm going to write it AB because of alphabetical order. And then lastly, we're going to have L stands for last. And that means we've got B and B, because these are the last terms within these parentheses. So that turns into B times B. Okay? Let's go ahead and do the math here. A times A equals A squared. A times B equals AB. A times B equals AB. B times B equals B squared. Okay? So let's add these together. I'm going to, or put these together. So I've got an A squared. That's positive. Okay? Here we've got a positive AB, so plus AB. We've got another positive AB, so plus AB. And then we've got a positive B squared, or B to the second power, so plus B to the second power. Now the last thing we have to do is, are there any like terms? Let's look at it. Here we've got A squared. Is there any other term that has an A squared in it? Nope. 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 So I'm going to write down A squared. Now, are there any other terms that have AB as the variable? Well, let's look. AB is here. AB, yep, this one, these two. And what about this? Nope, no AB there. So since I have one AB and two A and a second AB, that's going to be a positive 2AB because I've got two groups of AB variable. So 2AB. And that takes care of that. And then lastly, I've only got one term left, B squared. It's a positive, so that's going to make it plus B squared. And that is my answer. That's one way of doing it, FOIL, okay? The other way that he mentioned to do it is you could have, again, A plus B, quantity A plus B squared is the same thing as A plus B multiplied by quantity A plus B. Okay, so what he mentioned is we have two terms here, right? We've got this term and this term. So we're going to draw a box with two boxes, one for each term. We're going to put A plus B. And then here we also have two terms. Got this term and this term. So we're going to write A plus, and then this is a B as well. I'm going to make this A look more like an A and less like a 9. So we need to have two boxes this way. So we've got A and B, A and B. Okay, so two terms, so we've got a 2 by 2 box. So now let's do our multiplication. A times A is A squared. A times B is AB. B times A is BA, but again, I'm going to write it in alphabetical order instead and make it AB. And then lastly, I've got B times B is B squared. Same thing as we had before. So we first write it out. I'm going to start out with my A squared. Get rid of that. Then a positive AB here. And that gets rid of that. And then a positive AB here, so another positive AB. And then lastly, I'm left with a positive B squared. And now we just have to combine like terms, okay? So here, there are no other terms that have an A squared in it, so I'm going to write A squared. Then my next one is AB. Any other terms with AB in it? Yes. Again, why did we write this in alphabetical order? Because if I had BA, I might not realize that BA is the same thing as AB, so I would have possibly not thought they were like terms. So when we write them in alphabetical order, it helps us recognize, oh, AB and AB, that's the same thing. So here we've got AB and AB are both like terms. So that's 2AB, and it's a positive, so plus 2AB. And then lastly, I'm left with a positive b squared. So that's the same thing that we figured out before. And then the last thing, got two ways of solving this too. So if we have y, quantity y plus 1 multiplied by quantity x plus y plus 3, okay? First way we can do it is the distribution property. We are going to start by, let's multiply the first term of y. We'll multiply that by y, by x. So that's y times x. And then we'll bring down the plus sign. And then y by that term, y times y. Bring down the plus sign. And y times 3. So y times 3. And now what I'm going to do is distribute the 1. So 1 times x. And because it's a positive 1 times by a positive x, it's going to be a plus 1 times x. Next one, positive 1 times by positive y is a positive 1 times y. And then positive 1 times by positive 3. So it's a positive, because it's two positives, so 1 times 3. Now let's do the math, okay? Y times x equals xy, because we're doing it in alphabetical order. Going to bring down the plus sign, so that gets rid of that. Now we've got y times y, which equals y to the second power, or y squared. So we get rid of that. Now we're going to bring down this plus sign as well. And then y times 3 equals 3y, because we put the coefficient to the left of the variable. So that gets rid of that. Now we're going to bring down this plus sign as well. And 1 times x, we don't have to write down the 1 anymore because we know it's just 1x. So that gets rid of that. Plus, we're going to bring down that plus sign. 1 times y, again, just equals y because we know we've got 1y, so we don't have to write the 1. And then bring down the plus sign again. 1 times 3 is 3. Now, let's combine like terms, okay? So here we've got xy. Are there any other terms that have xy in it? Nope, y squared. That's just an x. That's an x. That's a y. That's a 3. So xy, we have to have this exact same combination in order for it to be a like term. This has an x in it, but there's no y. This has a y in it, but no x. This has just an x. So it has to have the exact same variable of xy. So that gets rid of that. Now let's look. Any other terms that have y squared in it? We've got an x, a y, and a 3. So nope, that's the only one that has y squared. It's a positive, so we're bringing down the plus sign. So here, let's see this. We've got any other variables that have a x in it. We've got x. Oh, yep, this is an x. This is y, so no, we don't. And this doesn't have a variable. So these two are like terms. So we've got 3x plus x equals 4x. And since it's a positive 4x, that's going to make that a plus sign. So we go ahead and cross out that. Next, we've got y. Any other terms with a y in it? Nope. So it's a y, and since it's a positive y, we've got positive y. And then we are left with a 3. And it's a positive 3, so we're going to put plus 3. Now we have our answer. Fairly long. And my penmanship's horrible, but we understand that now. So that was one way of doing it. Let's try that box method that Mr. Pacheco showed us. So here's the box method. You've got, again, we've got quantity y plus 1 times by quantity x plus y plus 3. And again, I really apologize for my penmanship. It's too late for me. Save yourselves. All right. So what we're going to do is, because we have two terms here, and here we've got three terms, we want to create two boxes along the top where we'll do a y plus 1. And then this term here, since it's 3, we're going to do 3 boxes. So we've got 1 box, 2, 3, and then we just make it well-rounded. So now we're going to bring this part down, x plus y plus 3. Now let's do it. X times by y is x, y. X times by 1 is x. Y times by y is y squared. Y times by 1 is just y. 3 times by y is 3y. And 3 times by 1 is 3. So now, we'll go ahead now and do the first term, xy. Are there any other xy's in here? Nope. So we're going to start off with x, y. We'll cross that out. Now we're going to do an x. Got an x. Are there any other terms that have an x in it? Nope. So we're going to go ahead and and because it's a positive x, we're going to do plus x. Now, let's go ahead. The next one is y squared. Are there any other y squareds anywhere? Nope. So we're going to do, and because it's a positive y squared, we're going to do plus y squared. Now we have a y. Any other y's? Yep, we've got 3y. That's like terms because this is a y and this is a y. So we can add it. 3y plus y equals positive 4y. Because it's positive, we're going to do a plus 4y. And then we're left with a positive 3. So that's going to be a plus 3. Okay, so we've combined like terms. Here's our answer. Choose however you prefer to do it.